Most of the demos in this learning path so far have focused on the features available in the JavaScript programming language. The ultimate goal of learning JavaScript, though, is to influence the behavior of your web application. While JavaScript can be used on the server side of a web app, specifically using the Node.js framework, all the demos of this learning path have focused on running JavaScript from a web browser, that is, on the client side of a web app. We will now see how JavaScript can be used to control the document object model, or DOM, of a web page. For this demo, we will make use of two different files, an HTML file and a JS file. We begin though by defining the HTML. So you see here that it already contains a few elements. There is a head element as well as a body element, which includes an h2 header, and within the script tag, we point this HTML to a related JavaScript source file. When an HTML page is loaded into a web browser, it is first parsed and then its elements are rendered in a tree-like structure, which is the document object model. It is that DOM which JavaScript has the ability to manipulate. So what elements can we include within this HTML? Well, in addition to the h2 element, I'm just going to add in a few more. There is a paragraph element at the top, which has an ID of JS title, and the text for this just says JavaScript. This is followed by a bold element, so the text within that will appear in bold font. And this is followed by a paragraph element with the ID of JS text, and you observe that it contains the text JavaScript is very easy to learn. However, this is structured in such a way that this paragraph has a few child elements. There is the I element for italic text, and within that, there are two bold elements which contain the text very and learn. Next, we have an I element to which we apply the class JS description. Then there is an h2 element with the ID of JS style, and we apply a style where there is a red color for the text JavaScript. All of these elements are those which we will access from our JavaScript source file, and we will play around with them. We are not quite done with the elements, however. So right after the h2 element, I'm just going to add in a button, and you can see from its onClick attribute that it has been set to a particular JavaScript operation. So we can directly embed JavaScript code for the onClick property, and in this case, we retrieve the h2 element right above the button by invoking document.getElementById, and we pass along the ID of JS styled. Then we change the color of its style to green. So when someone clicks on that button, that JavaScript text will turn from red to green. You will also observe that the script tag, which points to the related JS file, is included at the very end. This means that the JavaScript source will load once all of the other elements defined right above it are loaded on the page. Alright, with that done, let us now head over to the JavaScript source itself, where we begin by enabling strict mode. We follow this up by retrieving the text JavaScript at the top of the page, and this we do by using document.getElementById, and we reference the ID of JS title. So this is assigned to the variable language, and following that, we use the variable representing that element in order to access its inner HTML value, which we print to the console. Alright, so now make sure that you save down both the HTML as well as the JavaScript, and then heading over to the web browser, you can load the HTML page. So the page has now been loaded into the window, and we can take a look at some of the different elements which are rendered here. What we're going to display in the console is the content of JavaScript, which appears right below the top header. Further down, we also have JavaScript appearing in red text, and at the bottom we have the Click Me button. Alright, let us head over to the console now, and we observe that we have successfully retrieved the element with the ID of JS title, and we have rendered its inner HTML content to the console. So this currently has a value of JavaScript. Let us ensure that a button operates as expected. So I'm just going to go ahead and click it. And the red JavaScript text has now turned to green. We can quickly confirm that it wasn't really a fluke. So I'm just going to reload the page. So the JavaScript text is back to being red. But on hitting the click me button, it does turn green once again. Alright, so the button works. And let us head back to the source file. And now it's time for us to retrieve all of the B tags, that is, all of the elements containing bold text. And for that, we invoke document.getElement by tag name, and we pass in the argument of B. So this will return all of the B elements, and we can print all of them out to the console. I'm just going to head over to the browser again and then hit reload. But before that, just take a look at the HTML on the left, and you'll see that there are 3 different bold elements within our page. So when we refresh the page, we can see that what is printed in the console is an HTML collection, and there are 3 elements within that collection, and each of these is a bold tag. I'm just going to expand this collection now, and then expand the first of the bold tags. And you can see from the value of its inner HTML property that this represents the text finding HTML elements using the tag name. Alright, we can expand the second of the bold tags, and viewing its inner HTML attribute, this represents the value of very, and going further down and then expanding the third of these bold tags, this represents the text of learn. So we have now covered how we can retrieve different elements using either their tag names or their IDs using JavaScript. And it is also possible for us to edit those elements, as we did with our button, which changes the color of the JavaScript text. Heading back to the source though, let us now access an element from the array of bold tags. So here we can reference this as any other array. So here we access the element at index 0 in the B tags array, and then print out its inner HTML to the console. And heading over to the browser, sure enough, this prints out the text, finding HTML elements using the tag name. Heading back to the source code, we will now retrieve all of the P elements, that is all of the paragraph tags, and once again we invoke document.getElement by tag name, passing along P as the argument. And then we will print out the length of this P tags array which will be returned. And heading over to the browser, we can see that there are a total of 2 paragraph elements within our DOM. And you can confirm this by taking a look at the HTML. Heading back to the source file now, it is now time for us to retrieve the element with the ID of JS text. So this is the one which contains the text JavaScript is very easy to learn, where the text very and learn appear in bold. So can we retrieve those bold elements from within this JS text element? Well, that is what we're going to try, where we invoke the getElement by tag name function from the JS text object. Whereas previously we invoked this from the document object, which returned all of the matching elements from the entire document. In this case, all of the bold elements will only be retrieved from the JS text element, and we will print these out to the console. So reloading the page now gives us an HTML collection of 2 different bold elements. I won't expand everything here, but if you want, you can take a look at what each of these elements represent, and you'll be able to confirm from their inner HTML that they represent the text very and learn. In the previous video, we saw different ways in which we can retrieve the elements from the DOM of a web page using JavaScript. We also covered how we can retrieve one element and then retrieve its child elements as well. While doing that, we made use of 2 different methods, getElement by tag name and getElement by ID. It is now time for us to invoke one more method in order to retrieve an element in JavaScript, and this is getElement by class name. In our HTML page, we have some text which appears in italics So it is defined within an I tag, and we have applied the class JSDescription to that element, and we can now retrieve it by using the class name. But since multiple elements can have the same class applied to it, what this method will return is in fact an array of elements. In our case, there'll be an array of just one element, so we will print out the inner HTML of the first element which is returned. Heading over to the browser and reloading the page, the inner HTML for our element is JavaScript is a programming language. Heading back to the source, we explore one more way of retrieving the element, and this involves invoking the function querySelectorAll. The argument to this is a CSS selector, and in our case, we can retrieve the same element as we did previously by specifying the CSS selector as i.jsDescription. I here represents the italic tag, and JSDescription is the name of the class. Since the CSS selector could also have multiple matches, what this method returns is an array, and we will now print out the inner HTML of the first element in that array. And the output is exactly the same as before, since we have essentially accessed the same element using a different method. Within our JavaScript source file, we have so far been retrieving various elements using different methods, but we haven't made any modifications to the page just yet. That is precisely what we will do now, but first, let us retrieve the element which has an ID of JS title. So this is going to be in the variable data, and we will first print out its inner HTML value to the console. And from the browser, we can see that this contains the text JavaScript. Just to refresh your memory, this is the second line of text which appears in the HTML page on the left. Alright, it's now time for us to modify this, and we will now set its value to programming with JS. So we are simply setting the value of data.innerHTML to this modified value, and we will also assign the same value to a variable new data. Following that, we will also print out new data to the console, and heading over to the page and hitting refresh, you'll observe that the new data in the console says programming with JS, and importantly, in the HTML page, that same text can be seen. So this is a simple example of how JavaScript can be used in order to modify the contents of a web page. This is accomplished by modifying the document object model or the DOM of a web page. Since JavaScript is used in order to manipulate the DOM of a web page, it is to be expected that JavaScript does include a number of different functions which are specifically meant to work with the DOM structure. Since the DOM is essentially a tree data structure, each of the elements of that tree are referred to as nodes. In this demo, we will focus on various methods which are available in JavaScript in order to access the DOM elements as nodes, and also the children for each of the nodes. We will once again be working with an HTML page which is manipulated from a JavaScript source file. So this nodes.html starts off with an h2 header and then some bold text, but following that we have two different paragraph tags. One of these has the ID of JS title and the other one of JS description. Within that paragraph tag there is an italic tag which contains the text easy, and following that we have an unordered list represented by the UL tag. At the moment, this unordered list has only a single element, which is a list item with the text Python. At the very end, we have a script element which points to the JS file, which will be used to manipulate the DOM structure. Alright, heading over to that source file. Once we enable strict mode, the first thing we will do is to retrieve the element which has the ID of JS description, and then we will print out its inner HTML to the console. To just test it out, we load the HTML page in the browser, and once it's done loading, we can take a look at the various elements which are rendered on the page. The one we are trying to access has the ID of JS description, and this is the one which has the text JavaScript is easy to learn, where easy appears in italics. And pulling up the console, it is that inner HTML which we see here. I'll just expand this frame a little bit, and we can see here that easy appears within the italic tags. Let's head over now to the Elements tab here, and you can see that this in fact represents the DOM of our web page. At least on the Chrome browser, if you hover over a certain element, you'll see it highlighted on the page itself, and each of the elements which have any children have this little triangle to its left. We can now expand this paragraph tag, and we observe that one of its children is the I element. So, given that we can access this particular node in our JavaScript, how exactly do we get to its children? It is not just this paragraph tag which has children, but also this unordered list, and expanding it gives us the li element which is its child. Alright, to access the children, we can now head back to the JavaScript source file, and all we need to do is to access the child nodes property of the element. Since each element or node can have multiple children, this attribute will in fact give us an array. So heading over to the browser and reloading the page, we do see that there are 3 children for this particular element. So expanding it, we can see that this contains some text followed by an I element for the italic tag, followed by some more text. We can view the first of these text elements. So I'm just going to expand this, and you can see from its data attribute that this represents the text JavaScript is. There are several other interesting properties as well. Base URI tells us which particular HTML file this element can be found in. The child nodes attribute we have already seen gives us an array of child nodes, and in this case there are no children to speak of, which is why that array is empty. Beyond that, you'll also observe that there is a first child property as well as a last child property, and this is something which is applicable if the node does have children. It is also possible to head to the siblings of this particular node using the next sibling and the next element sibling attributes. Scrolling a little further down, you can see that there is a node type attribute, which is a number representing the type of node. The number 3 represents a text node, and we will explore the other values of this node type attribute a little later. You'll observe that it is also possible for us to access the parent node, and the previous sibling of this node can be accessed as well. We will explore many of these attributes just a little later in this demo. For now though, let us quickly expand the next of the elements, which are the children of JS description. And we can see here that this italic element includes many attributes which the previous text node did not. This particular element has a single child node, which is a text node. And we can see from the inner HTML that the text is easy. If you'd like, you can continue exploring the different attributes of this particular element, or we can go ahead and take a look at the next text element as well. Alright, I'm just going to have a quick round of this, and then we can head back to the source file, where we will use our JS description node, and then we will access its first child property, and then within that, we will access its node value. The first child of JS description is a text node, and we can access the value of that text using the node value property. In fact, we will also access the text of the last child of the JS description node, which is also a text node. And heading over to the console, we get the values of JavaScript is for the first child and to learn for the last child. The text easy is part of the middle child of the JS description element. In fact, we will now access that by going to the element at index 1 of JS description.child nodes, and then we will access its own first child .node value. And reloading the page, we get the value of easy. So this should give you a fairly good idea of how we can navigate the DOM structure of a page. Heading back to the source though, let us access the node value attribute of the top level document itself and head over to the console to see what it returns. Well, this returns a value of null. We now continue exploring some of the other attributes of the elements. This time we retrieve the JS title element and then print out its node name attribute. This is a paragraph element, which is why the node name is P. Heading back to the source, we will now print out document.nodename, and this gives us a value of hash document. Heading back to the source now, we will now take a look at some of the different node types of the nodes in our document object model. First, we will print out the node type for the top level document itself, followed by the node type for the JS title element, which is a paragraph element, and then the node type of its first child, which is a text node. And we can see here that the document node type is 9. The node type for an HTML element such as a paragraph is 1, and the node type for a text node is 3. So in this demo, we have traversed the document object model tree structure using various attributes of the nodes in that tree. In the next video, we will see how exactly we can manipulate the DOM using various functions available in JavaScript. Previously in this course, we have invoked several functions from within our JavaScript code in order to retrieve elements from within our web page. Specifically, we have been retrieving specific nodes from the DOM representation of our web page. Let us now go ahead and begin making changes to the DOM structure. Before we get down to it, I'd like to draw your attention to the specific elements we will be modifying. Looking at the web page on the left, you see that we have an unordered list which has a single entry with the text Python, and this is what we will be changing in order to include more entries within the unordered list, and will also add elements before and after it. So let us get down to it. Heading over to the source, we will first retrieve the unordered list element, and once again we will do this by invoking getElementById, and this will be followed by creating an element which we will add to the unordered list. So this is going to be an li or a list item, and we create this by invoking the createElement function of the document object. This method can be used to create any kind of element, and the type of element is specified in the argument. So this will return a single list item element. However, we have not connected it to the unordered list just yet. Before we get to that, however, let us see what exactly this list item element looks like. So we will print it out to the console. And from here, you can see that it includes the li tags, but nothing within them. We can head over to the element tab, and then from here, we can view our DOM structure, and specifically, let us head over to the unordered list, where this particular list item we have created should be added to the one which is already here and contains the text Python. The way to do that is to set the text content attribute of our list item. So we will now set this to JavaScript, and once again print out the list item to the console. And heading over to that console, we can see that it now includes the text JavaScript. You'll observe that the text JavaScript also appears in the previous console.log statement, since the variables which are printed out in the console are dynamically bound to their values. If we do update those variables, their values are updated in the console as well. Just as a reminder, we have not yet added this list item containing the text JavaScript to our unordered list. But we won't do that just yet. Instead, we will create one more list item element by invoking document.createElement, and we set the text for this particular element in a different way. Instead of setting the text content property, we'll first create a text node by invoking document.createTextNode, and then we pass along as an argument the text of the node itself. So this is going to be Java. So with these two statements, we have an li element as well as a text node. And in the last of these lines, we will append the text node as a child of the li element. And we do this by invoking the append child method of the list item 2 variable. And we can now take a look at the contents of list item 2. And heading over to the console, we observe that its contents are similar to the previous list item, where we have the li tags with text between them. So for the first li element, when we set the text content attribute to JavaScript, we in fact added a text node as its child. The end result, however, is that we have two list item elements, which we now need to add to our unordered list. Heading over now to the Elements tab, and then to the unordered list, let us say we want the first list item which we have created for JavaScript at the top of this unordered list, and we want the text Java to appear at the bottom. So how exactly can we do this? Well, we have already retrieved the unordered list element previously in the code, so we will now use that to prepend the first list item to that unordered list. So this will add the text JavaScript at the head of that list, and then following that, we invoke the append function to add the second list item to the bottom of that list. So let us head over to the browser to see whether our changes have taken effect. And on reloading the page, we can see from the HTML that the unordered list now has JavaScript as the first element and Java as the last one. And expanding this element in the DOM structure, we can see that both of the list item elements have been placed in their respective positions. So we now know how to prepend and append elements to an unordered list. However, what if we wanted to add elements before and after some of the existing elements in our page? So our unordered list lists down 3 different programming languages, but there is no header for this list. So let us go ahead and create one once again by invoking document.createElement. This element will be an h4 header, and we set its text content to "This is a list of useful programming languages." And how exactly do we make sure that this header appears just before our unordered list? Well, we can invoke the function document.body.insertBefore. This takes in 2 arguments: the element which needs to be inserted into the DOM and the element before which it needs to appear. In our case, we want this h4 to appear before unordered list, hence the ordering of the arguments. Alright, we head over to the browser to see whether this new h4 header appears before our unordered list. And the answer is yes. So we have covered one way of adding a new element to the DOM. We can now take a look at how exactly we can style this element. Heading over now to the code, we will now apply h4.style.backgroundColor and set this to a value of cyan. Many elements will have a style property, which in turn will have a number of attributes of its own. In this case, let's see whether the setting of the background color has any effect. And the h4 header now has a new background color. So we now know how to insert an element before an existing element in the DOM. However, what if we wanted some text to appear after our unordered list as well? While we could use the insert before method, which is available in JavaScript, there is no insert after function. So we will explore a different way of adding elements to the DOM. Heading back to the source, we will first define the element which we wish to add to the end of the unordered list. So this will be an h3 header, where the text content says this marks the end of the unordered list. And in order to add it to the end of the unordered list, well, we still invoke document.body.insertBefore, and the first argument is the h3 header which we wish to add. However, note the second argument here. Here we specify unordered list.nextSibling, and this means that our h3 header will be added before the next sibling of unordered list. In effect, it will be added after the unordered list. To test this out, we head over to the browser and refresh. And sure enough, the H3 header now appears right after the list. Now that we know how to modify and even add elements to the DOM structure, what if we wanted to get rid of one element which is already on the page? For example, what if we wanted to remove the JS title element which currently contains the text JavaScript? Well, we first retrieve that element using getElementById, and in order to delete an element from the DOM, all we need to do is to invoke its remove method. So we call jstitle.remove. So we can now test this out, but before reloading the page, observe that both in the DOM structure as well as on the page on the left, the JS title element is still present. But when we do refresh, that has disappeared. So we have now successfully deleted an element from the DOM structure of a web page. So in this case, we were able to successfully retrieve an element by its ID and then remove it from the page. But while in this case, we retrieved one of the nodes in the DOM structure and then explicitly removed it, it is also possible for us to remove the child node of an element. In this case, we retrieve the first list item element from our unordered list by accessing unorderedList.firstElementChild. This will give us the list item element which contains the text JavaScript. Following that, we remove this element from the unordered list itself by invoking unorderedList.removeChild. The argument to this is the child element which needs to be removed. So let us save down our source and then head over to the browser to see whether the text JavaScript disappears from the page and also whether this list item element disappears from the unordered list. So on hitting reload, we see that our unordered list is now down to 2 elements. We can confirm this by expanding unordered list in the DOM structure, which no longer contains the JavaScript element. We will continue playing around with this unordered list, and now we will see how we can substitute one of the existing children of this list with another. So we'll go ahead and first create a new child element to be added to the unordered list. This is once again a list item element, and this contains the text Go. The goal for us now is to replace one of the list item elements, specifically with the text Java, with this newly created element. And the way to do that is to invoke our unordered list's replaceChild method. There are 2 arguments to replaceChild, the first of which is the new child which needs to be included, and the second is the child which needs to be removed. So we can go ahead and test this out. And we now see that this unordered list now contains the items Python and Go, and Java has disappeared. With that, we come to the end of this demo, and this once again was an illustration of how we can use JavaScript in order to manipulate the elements of a web page's DOM structure. Since the DOM is essentially a tree data structure, all of the elements within it are nodes, and we can access each of the nodes individually and also access their children as well as siblings. Now that you have some familiarity with manipulating the DOM of a web page using JavaScript, we will now see how we can perform such a manipulation periodically in order to generate an animation on our web page. So in this case, we have an HTML within which we have a style tag, and inside it we have defined the styles for 2 different elements within our page. The first of these is a square, and this is a square which is 500 pixels wide and 500 pixels high, and it has a yellow background color. Next, we include a circle with the ID of circle. The width and height are 50 pixels, and we set its top attribute to 450 pixels, which means that it will appear in the bottom left of the square. We do this by including a div tag where we have the square, and inside that div, we place the circle. So what exactly are we going to do with the square and the circle? What animation are we going to generate? Well, if you look further down in this HTML, we have a button, and we're going to set things up in a way where hitting the button will move the circle from the bottom left to the top right of the square. That movement will be defined in a function called animation, which has been set as the onClick method for the button, and the definition of that function will be within our JavaScript source file, which is animations.js. So, heading over to that file, we first enable strict mode, and this is going to be followed up with the definition of the animation function. We start this by retrieving the circle element by invoking the getElementById function, and then we set a value of a location variable to 450. This will track the location of our circle within the page. From the HTML, you will recall that the starting location of our circle is 450 pixels from the top. Now, in order to produce some kind of animation, we will need to move the circle periodically on the page. And in order to perform any operation periodically, we can make use of the setInterval method in JavaScript. The arguments to this include a function which needs to be executed periodically, and the second argument is the frequency with which it needs to be executed. In our case, we will run a function called frame every 10 milliseconds. So it is within the frame function where we will need to define the movement of our circle. So let us get right down to it. First, we will need to define when exactly the circle's movement will stop. That is, we need to set a bound for the setInterval function. We will do that when the value of the lock variable is 0. So for each invocation of the frame method, we will check for this value, and if it is 0, we will invoke the clearInterval method. This complements with the setInterval, and note how we link this clearInterval with the setInterval we have defined. The setInterval function returns an ID value which we assign to the variable time, and when invoking clearInterval, we pass that ID as the argument in order to explicitly link this clearInterval with a setInterval. Alright, so this defines when exactly the repeated execution of the frame function will end. But until this condition is satisfied, what exactly are we to do at each call to frame? This is what is defined within our else block, where we first decrement the value of the lock variable. We then update the style.top attribute of our circle to the newly updated lock value, and then we also update the style.right attribute to the updated lock. So in effect, at each iteration, we are moving our circle 1 pixel to the top and 1 pixel to the right, which means that with each invocation of frame, our dot moves towards the top right. You can see from the value of lock that the total number of iterations is 450, and with an interval of 10 milliseconds, it will take 4.5 seconds for the circle to move from the bottom left to the top right. Alright, it's now time for us to test out our animation. So I'm just pulling up the animations.html in the browser. And once the page loads, we can see that we have a yellow square with a red circle in the bottom left. Right below that, we have a move button which we will soon hit. I have also just pulled up the console so that you can see how exactly the DOM is updated at every iteration. First though, let's check the functionality of the code we have just implemented. So hitting the move button gradually moves this circle from the bottom left to the top right exactly as expected. So now that we know our code works, let us examine how exactly this modifies the DOM. So I'm just going to right click on this and hit inspect. And from the DOM on the right, you can see that for this circle, and specifically its style attribute, the top and the right at the moment are 0 pixels. But when we hit the move button, I'm just going to slow things down so that you can see exactly how these attributes get affected at each iteration. So when we hit the button, the circle's position gets shifted to the bottom left, and when we hit the button, it gradually moves towards the top right. I'll just play this one more time. And once again, you can trace the movements in the DOM structure. So while you would realistically not implement animations in this primitive fashion, if you do need to manipulate the DOM periodically, you know that you can use a combination of set interval and clear interval to serve your purpose. And this is also a cool way to visualize how exactly JavaScript has the ability to manipulate your web page's DOM structure. One common use case of JavaScript is to respond to certain events when a user interacts with your web page. For example, a user may click on a part of the web page, which is very often a button. A user may also hover over certain elements of the page, or they may also right-click on some element. Each of these can be recorded as events in JavaScript, and there are constructs available in the language in order to listen for such events and to respond to them. We will now take a look at one such event listener and handler, and for this demo, we will make use of an HTML which has many similarities to one which we used a little earlier in this learning path, where we integrated some counters into our web page. So in this case, we have three different buttons on our page. One of these is an increment button with the ID of inc button, then a decrement button, and then a status button. As the names imply, hitting the increment button is meant to increment the value of a counter, decrement will decrease a counter's value, and the status will show the overall status of the two counters which we will integrate. The running status of both the increment and the decrement counters will be displayed within the div tags at the end of the page. The value of the increment counter will be recorded in the incount div, and the dec count div will keep track of the decrement counter. Alright, let us now head over to the accompanying JavaScript source file, and we begin as usual by enabling strict mode, and we also initialize two variables, incount and decCount. So these will be the two counter variables, and then following that, we assign a function to execute when all of the elements in our HTML page load in the browser. So this we assign by setting a value to window.onload. Within that, we first retrieve two of the three button elements in our page, and then following that, we will assign a function to execute when someone clicks on the increment button. So this is done by setting a value to incButton.onClick. In effect, this is an event handler itself. This listens for the event of someone clicking on the button, and when that does occur, the function which we assign to the onClick attribute is executed. So how exactly do we handle the event of a user clicking on this button? Well, we first increment the value of the incount variable, and we then display the value of incount in the div tag which is below the buttons. Specifically, this is the div tag with the ID of incCount, which we first retrieve and then update its inner HTML to show the value of the increment counter. So we have now defined what function needs to be executed in the event of a user clicking on the increment button. And we have done this by setting the value of incButton.onClick to this anonymous function. Well, we don't need to necessarily define a function in this manner. In fact, we can define a named function as well and assign it to a button's onClick property. So in this case, we define one called countDec, which is going to be attached to the decrement button. Here we decrement the value of the decCount variable and then update the div element with the ID of decCount with the decrement counter value. So we now have the decrement button as well as the function which needs to be executed when someone clicks on it. However, we haven't quite linked the two together, which we will now do by setting its onClick property to this countDec function. So the onClick properties of any button elements are in fact event listeners and handlers. Let us go ahead and ensure that our code works as expected. So we pull up the HTML in a browser, And once the page loads, we can see the 3 different buttons which are included. And I'm just going to pull up the DOM for this page so that we can see how it gets updated each time we hit one of the buttons. So let us go ahead and hit increment, and you can immediately see that the div element corresponding to InCount now has a child. And this is also reflected in the text below the buttons on our web page. If you want, you can just go ahead and hit the increment button a few times, and each time you'll observe that the DOM gets updated. And as a result, so does the web page. Testing out the decrement button, clicking it does include some new text within the web page itself, and the DOM has also been updated so that the dec count div now has some text. I'll just go ahead and hit each of these buttons a few more times. But what is important is that each of these buttons has an event listener which checks for clicks on the button itself. And when that does occur, we are able to define what action to take. In this case, we simply add some text to the inner HTML of these div elements. The question now is, what can we do about this status button? So we haven't really defined any event listener or handler, and this is precisely what we will do when we head over to the source code. We now define a function called IncDecValue, and this is what will be executed when someone clicks on the status button. And you'll observe that the code itself is rather simple. It simply pops up an alert message where it prints out the value of both the InCount and the decCount variables. So now that we have an event handler function, note how exactly we link this handler to the event of someone clicking on our status button. This is where we invoke the status button's addEventListener function. As the name suggests, this adds an event listener to the particular element, in this case the status button, and the first argument to the function is the type of event to listen for. Here we specify a value of click, and the second argument is the event handler itself. In our case, this is the IncDecValue function. This is synonymous with adding the function as the value of the onClick attribute of the status button. But this is a generic event listener method. There are other types of events which we can listen for, such as Mouseover events or even Mouseover events, and we will explore some of those a little later in this learning path. For now though, let us make sure that the status button is able to listen for click events. So we'll now go ahead and reload the page, and I'll just hit the increment and decrement buttons a few times to make sure that adding the new event listener has not affected their functionality. And once we are satisfied, we can hit the status button, and sure enough, the alert message pops up giving us the status of both the increment and decrement counters. So this served as a quick introduction to event listeners and handlers in JavaScript. We will explore this in a little more depth in the next video. The purpose of this demo is to define a variety of event handlers. In the previous demo, we took a look at the click event handler, but we will now explore some of the different events which can be listened for and then handled. For example, if you were to alter the text in a text box, or if you were to hover your mouse over a particular item. As always, we have an HTML page along with a JavaScript file, but for this demo, there is also a directory called images where there are two different PNG files we have. I'll just show each of them to you. So this is one called Wi-Fi off.png, and there is one called Wi-Fi on. In the demo, we will code up our JavaScript in such a way where clicking on a particular element of the page will pull up the Wi-Fi on image, and then releasing the mouse button will bring up the Wi-Fi off image. Alright, it's now time for us to head over to the HTML. Heading straight to the body element, after the H2 header, we have a script tag, and this is followed by a bunch of HTML elements to which we will attach listeners. The first of these is a button, and the text on it says, to get the time, click me. As you may have guessed, clicking on this button will set off an event handler which will retrieve the current time, and it will display that in the next tag, which is the paragraph tag with the ID of current time. Next, we have an input element, specifically a text box, and once a user enters a word here, we will convert that word into uppercase characters. The next element on our web page is a div element with an ID of mouse. So this is going to be a rectangle with a height of 10 pixels and a width of 120, and its background color by default is pink. We will, however, include listeners for this particular div element so that its color changes when a user's mouse hovers over it and then changes back when the mouse pointer leaves the div area. And then we have an image, which by default is set to the Wi-Fi off image we just took a look at, but we will define a listener and a handler in such a manner that when a user clicks on this image, it toggles to the Wi-Fi on image. Alright, these are all of the elements for our web page defined within our HTML file. It's time now for us to define all of the event handlers, for which we head over to the JavaScript source. Once strict mode has been enabled, we will define a window.onload function. And before we assign any event handlers, I'm just going to leave this blank and then save things down and pull up the HTML in the browser. The purpose of this is to view all of the different elements on our web page and see how they behave without our handlers in place. So by clicking on this button, nothing happens. Once we enter a word in this text box, again, there is no event. If we hover our mouse over this pink spot, there is nothing going on. And if you were to click on this Wi-Fi image, there is once again no visible change on the web page. So let us now begin defining some listeners and event handlers. First, we define a function called displayDate, and this is one which will set the inner HTML for the element with the ID of current time to the current date, which we can retrieve by invoking the date method. Note here that we are accessing the element with the ID of current time directly using the ID itself. This is something which is possible in JavaScript. So when exactly do we want this displayDate method to be invoked in order to update the current time element? Well, that is when someone clicks on the button at the top of our page, and that button has an ID of time. So we set the onClick property of that button to our displayDate event handler. So let us go ahead and make sure that our changes have taken effect. So you need to reload the page, and then following that, when we click on this button, the current date is displayed right below it. So that is the paragraph tag with the ID of current time. Alright, we have now added an onClick event handler, but this is something which we have taken a look at earlier on. It is now time for us to add an event handler for the text box element right below this. From the HTML, you'll observe that the text box has an ID of convert. And what kind of event can we attach to this? Well, we will now define a function called convert into uppercase. And this time we retrieve the element by invoking getElementById. So we retrieve the text box element, and then we transform the contents of that text box into uppercase by accessing the contents using the value property and then invoking the toUppercase method. So it's now time for us to set this particular function as the event handler for the text box. But what kind of event are we listening for? Well, there is one called onChange, which listens for any change to the text box. So if you were to type any characters into it and then hit enter, then the convert into uppercase method will be invoked and the contents of the text box will be transformed into uppercase text. So we can now test this functionality out, and heading over to the HTML, I'm just going to type in some text into the box, and when we hit enter, the data has been converted into uppercase characters. So we have now attached two different event listeners and handlers to our web page. We will go ahead and add a third one, and this is to do with the event of someone bringing this text box into focus, either by clicking on it or by navigating to it from their keyboards. That action is called bringing the particular element into focus, and there is an on-focus event which we can listen for. So, heading back over to the source code, we will now define a function to handle that event, and this is called onFocus. We first retrieve the text box element and then set its background color to yellow. So now that the handler has been defined, we will map this to the onFocus property of the convert element, that is the text box. Now to test out the changes, I'll just reload the page, and you'll observe that the text box is white by default. But now I'm just going to click it in order to bring it into focus, and the background has promptly changed to yellow. We can now go ahead and then type in some text and hit enter, and that gets converted to uppercase. You'll notice though that the background color of that element will continue staying yellow because we don't have any handler to change it back to its original white. In the previous video, we listened for and handled events related to the button at the top of our web page as well as the text box right below it. We now turn our attention to the next element on our page, which is the pink section with the text mouse over me. JavaScript has an onMouseover event, which is used to listen for the hovering of a mouse over an element. We will use that event listener in order to change the background color of this div element from pink to some other color. Specifically, we have a Mouseover function in order to first retrieve the mouse element from the page. So this is a div element with the ID of mouse and a background color of pink. And when someone hovers their mouse over that element, we want to set the background color to green, and then also alter the text, that is the inner HTML for this, to thank you. We don't want this change to a green background to be permanent, however, for which we define one more function to handle the event of a user taking their mouse out of the zone of the div element. When that happens, we will change the background color of this mouse element to cyan and then alter the inner HTML to read mouse over me. So with these two handlers defined, we will now need to map these to different events. So we use the mouse element's onMouseover attribute and set this to a value of mouse over. So this means that when a user hovers their mouse over the div element, its color will change to green. And then we configure the onMouseOut attribute to our mouseout function. Saving down the changes, we can head back to the browser and then reload the page. And for a div element with the ID of mouse, by default the background color is pink. However, if we were to hover our mouse over it, it promptly changes to green, and the text within it also gets altered to thank you. If you were to drag our mouse pointer outside this div element, the background color changes to cyan, and we get the message mouse over me. So both of our events, onMouseover and onMouseOut, have been configured. If you want, you can just play around with this by moving the mouse pointer over and then out of this element, and the color will keep flicking back and forth. Alright, it's now time for us to configure a handler for the event of a user clicking on the Wi-Fi image below. To do that, we head back over to our source code, and then we will define two different functions. One of this is called Wi-Fi on, and in this case we retrieve the image element and then set its image source to Wi-Fi on.png. You'll recall that by default this is set to Wi-Fi off. Similarly, we also have a Wi-Fi off method, and this is one which will set the image source once again to Wi-Fi off. So once again, we are going to introduce some toggling behavior here. So what are the events which these functions will map to? Well, there is an onMouseDown event, And the Wi-Fi on function will be executed when someone clicks on the image and keeps their mouse button down. And then once they release the mouse button, then it is the on mouse up event which will be triggered. And this of course invokes the Wi-Fi off method. So we now have listeners in order to listen for the holding down of a mouse button and for its release as well. So heading over to the page and then reloading it, by default it is the Wi-Fi off image which is rendered. But I'm just going to move my mouse over it, and the moment we click and hold down the mouse button, an on mouse down event has been triggered, and since we were listening for it, the Wi-Fi on function has been executed and the image has changed to this Wi-Fi on image. And the moment we release the mouse click, the on mouse up event has been triggered and our Wi-Fi off function has been invoked. So the image changes back to Wi-Fi off. You can hold down and then release the left mouse button a few times just to make sure that this behaves exactly as we intended it to. And with that, we have configured 7 different event handlers in this demo. There was one event for the clicking of a button. For the text box, we had 2 different events for the altering of its contents as well as bringing it into focus. For a div element, we configured on mouse over and on mouse out events. And then for the image at the bottom, we had the on mouse down and on mouse up events. You could configure the same event listeners using the add event listener method, which we took a look at previously in this course. And the name of the specific events to listen for is simply what we have covered in this demo without the prefix on. For example, instead of configuring the on mouse over attribute of an element, you will listen for a mouse over event and then point it to an event handler function. When you write JavaScript code, you are defining the behavior of your web application. There will be several occasions, however, where that behavior is determined by the settings of a particular user. These settings may be related to the browser which the user is running, which is why JavaScript has a browser object model in order to interact with the browser of your end user. There are a number of different objects which are available in order to interact with the user's browser, and we will explore some of them in this demo. So you see here that we have an HTML as well as a JS file as usual. And in the HTML, we have a button with the ID of new doc, and we will configure this in such a manner that when a user clicks on it, they will be navigated to a different page. Since that navigation is only possible from the browser, we will need to interact with the browser in order to tell it which page to navigate to. The next button has an ID of go back, and as the name implies, clicking on this will take the user back to the previous page in their browser session. Again, we will need to interact with the browser in order to accomplish this, and we will see how exactly that can be done when we start coding up the JS file for this demo. So we head over to that, and after enabling strict mode, the first thing we do is to get the width of the screen of our end user using the screen object. So we access the property screen.width. So we can print this out to the console now. And to see how this works, we can just pull up bomb.html in the browser, and we can see the 2 buttons here. And when we pull up the console, you can see that the width of the screen, at least in my case, is 1280 pixels. So the screen object is one of the components of the browser object model. We will access a few others in order to configure the behavior for these 2 buttons we have on our web page. Heading back to the source, however, we continue using the screen object now to get the height of the screen and then also to get the color depth. And from the console, you can see that the resolution I'm using for this recording is 1280 by 720 pixels, and the color depth is 24 bits. Alright, so we now used the screen object. It's time for us to use one more object in the browser object model, which is the window object. So in order to get the URL of the current page the browser is on, we can access the property window.location.href. And from the console, we can see that this is in fact a file located on my file system. It is in fact an href element, which is why we can click on this, and this will take us to the source of the HTML file. This is of course available in the sources tab along with the bomb.js source file as well. However, heading back over to the console and then back to the source file, where we access one more attribute from the window object, which is window.location.protocol. And this gives us the specific protocol which is being used in order to render the web page. In our case, since the web page is being pulled up from a file, the value of the protocol is file. For web applications on the internet, you can expect this value to be HTTPS or even HTTP. Heading back over to our source file now, it is now time for us to configure the behavior for the buttons on our page. So first we retrieve one of the buttons with the ID of new doc and then set a value for its onClick attribute. Specifically, this function will navigate the user to skillsoft.com, and in order to direct the user to that URL, we once again make use of the window object and invoke the function window.location.assign, whose argument is the URL we need to head over to. So to test that out, we head over to the browser and reload the page. And before hitting the button, I'm just going to close out of this console and then hit the load button. Sure enough, we are navigated to the skillsoft.com homepage. And this also happens in the same browser tab. So to head back to our own web app, I'm just going to hit the back button. And then from here, I'll just bring up the console once more. Alright, it's now time for us to configure this back button, which at the moment doesn't do anything. So in the source file, we first retrieve that back button, and then following that, we define its onClick behavior to go back to the last page in the browser history. And this can be done by invoking the function window.history.back. So with the file saved down, we head over to the browser and reload the page. And when we hit the back button, I'm taken over to the page which loads when bringing up an empty tab in Chrome. So we have now successfully made use of the screen as well as the window object in order to interact with the end user's browser. So heading back to the source now, we will make use of one more object which is available in the browser object model, and this is called the Navigator. We can use this, for example, in order to check whether the end user has enabled cookies on their browser using the cookie enabled attribute. So from the console, we can see that at least in my case, cookies are indeed enabled. A rather common feature of JavaScript applications is that you need to check what kind of browser your end user is running on, and you may configure your web page accordingly. You may also convey the information over to the server-side application, but in order to retrieve what kind of browser your user is running, you can access the property app version from the Navigator object. Beyond that, if you want to know what platform your end user is running on, this is also available using navigator.platform. So let's see what emerges, at least in my case, when I pull up these details in the browser. Well, in the case of the browser version, you can see the specific version of Chrome which I'm running. And in fact, the app version attribute also gives away details about my platform. For example, that I'm running an Intel processor on a Mac OS X, and the version of my Mac OS is also visible here. When downloading an application which has platform-specific versions, you may have noticed that websites have the ability to determine what platform you're running on, and they take you to the download page of the application for your specific platform. Well, if they use JavaScript, they may be using navigator.app version in order to get that information. Or more concise information, is also available from navigator.platform, which in my case is just Mac Intel. When exploring the browser object model in the previous demo, we made use of the window object. Well, in this demo, that is going to be our sole focus, where we will take a look at a few different options which are available when working with that window object. So this is the HTML page which we will be working with. You can see that it contains 4 different buttons, along with a div element at the bottom with the ID of history. So the first button will be configured so that clicking on it will open up a new tab or a new window in your browser and then navigate to a specific URL. The next button, which is a close button, will close down that window or tab. Then there is a history button, which will print out the number of elements which are present in your browser history. And then finally, there is a Wikipedia button, which, as the name implies, will direct you in the same browser window or tab to wikipedia.org. To configure all of these behaviors, though, it is time now to head over to the JavaScript source file. And we start off by setting a window.onload function. And for now, we leave the body empty. We can pull up the HTML in a browser and then make sure that all of the text and all of the buttons appear exactly as they are supposed to. You can just click on each of them to make sure that they don't really do anything. And with that done, we can head back to the source file to begin configuring the buttons. First, we retrieve the open as well as the close buttons, and then we set a variable called new window to null. Following that, we set the onClick property of open button. So when a user clicks on it, a new window will open up and will navigate to skillsoft.com. To open up a new window, we invoke the function window.open, and its argument is the URL that window needs to navigate to. Invoking this function will return a handle on that window, which we capture in the variable new window. This is required in order for us to be able to close down that window. Speaking of which, we will now define the onClick attribute of the close button. Here, we check whether the value of new window is null, and if it is not, we can invoke its close method in order to close down that window. So this is only applicable if the user has previously opened up a new window by clicking the open button prior to this. Alright, it's now time for us to test out these two buttons. And for that, I'm just going to reload the HTML page in the browser. And now that we have these 4 buttons, let us click on the first one. This has pulled up skillsoft.com in a new tab in my browser. And this is because I have configured my browser to open up new pages in new tabs. From the point of view of our code, this means that the new window variable has been initialized to point to this specific window. So I'm just going to leave this open and then head back to the tab containing our HTML page. And now it's time for us to close down the newly opened window by clicking the close button. So in my case, before clicking on the button, the tab which has navigated to skillsoft.com is still open. But the moment I click close, that tab has disappeared. So our open and close buttons work exactly as configured. It is now time for us to configure the remaining 2 buttons on the page. So heading back to the source, we first retrieve the history button and then add an onClick property to this one as well. And inside this event handler, we first retrieve the history element, which is a div element, and then update its inner HTML with the length of the history array in the window object. Feel free to print out the entire history array if you like, but I'm just going to leave the history length. So heading over to the browser and reloading the page, on clicking the history button, at the bottom you can see that in my case, there are a total of 2 elements in my browser history. It's now time for us to set the behavior of the last button in our page. So retrieving the Wikipedia button from the source code, we can then go ahead and then set a value for its onClick property And this function is going to alter the window.location property to wikipedia.org. In this case, the user will be navigated to this URL in the same browser window. This is to contrast with the window.open function which we invoked earlier in order to open up a new window and then navigate to a specified URL. So let us head over to the browser and then check whether clicking on this button does take us to wikipedia.org in the same window. And the answer is yes. So we have now covered different ways in which the window object can be used in order to direct the user to a specific URL or to even access their browser history. So at this point, I'm just going to head back and then continue playing with our own web page. So I'll just click on the first button, which sure enough brings up skillsoft.com. Heading back to the home page, I'm going to click on the close button, and this still closes down the newly opened tab. Clicking on the history button, this time shows that there are 3 entries in my browser. And finally, the Wikipedia button still navigates to wikipedia.org. This course covered one of the more common use cases of JavaScript, altering the elements which make up your web page. This was accomplished by manipulating the document object model, or DOM. We took a look at the various functions available in JavaScript to retrieve DOM elements, access them as nodes in a tree, and then manipulate their contents. We then examined event listeners as well as event handling, and how these can be applied to the elements of a web page. Finally, we covered the browser object model, or BOM, which allows JavaScript code to interact with the browser of the end user. Having completed this course, you will have applied your JavaScript skills for a very common use case, influencing the behavior and appearance of your web page. You can move on to a course covering some other applications of JavaScript, such as form validation, and also explore advanced topics such as asynchronous programming.